So the first thing, if you want to decompose fraction into partial fraction, we have to identify if the fraction is a proper or improper fraction. So for proper fraction, there are few factors. The first one is a linear factor. So if you can see at the example that we have here, so in the denominator, we have two linear factors, x minus 3 and x plus 1. So to decompose into partial fraction, first we have to decompose into general partial fraction. So 2x plus 5 over x minus 3 times x plus 1. If we decompose into general partial fraction, we're going to have a constant over x minus 3 plus a constant b over x plus 1. Next, for the case of quadratic factor that cannot be factorized. If you look at the first example, x minus 1 over x times x squared plus 2x plus 2. So x is a linear factor, while x squared plus 2x plus 2 is a quadratic. A quadratic factor that cannot be factorized. If we can still factorize the quadratic, we have to factorize and we have two linear factors. But for this case, x squared plus 2x plus 2 cannot be factorized, so it is considered as quadratic factor. So when we express this fraction as partial fraction, we're going to have a constant a over the linear x, plus for the quadratic, we're going to have a linear factor. So, we're going to have a linear on top of the quadratic. So we have plus bx plus c over the quadratic factor, which is x squared plus 2x plus 2. For the second example, we have 2 over x squared plus 1 squared. So we have a quadratic that is repeated twice. And x squared plus 1 is a quadratic that cannot be factorized. So it is a repeated quadratic. So if we express as partial fraction, we're going to have a linear on top of x squared plus 1. So ax plus b over x squared plus 1. And since the quadratic factor is repeated twice, so we're going to have plus cx plus d over x squared plus 1 squared. Example 15 on page 17. Change 3 over x plus 2 times x squared plus 1 in partial fractions. This is obviously a proper fraction. X plus 2 is a linear factor. X squared plus 1 is a quadratic factor, but it is a quadratic that cannot be factorized. So we have to express the fraction in general partial fractions. So 3 over x plus 2 times x squared plus 1 equal to, for the linear factor, we have a over x plus 2. But for the factor that cannot be factorized, we have plus bx plus 1 over, bx plus c over x squared plus 1. Since we have a quadratic in the denominator, so for the numerator, we should have a polynomial of degree less 1 than the denominator. Next, equalize the denominator. We have a times x squared plus 1 plus bx plus c times x plus 2 over x plus 2 times x squared plus 1. But just considering the numerator, we have 3 equal to a times x squared plus 1 plus bx plus c times x plus 2. In previous example, to find the values of a, b and c, we substitute 3 values of x. But other than that, we can also find the values of a, b, and c by just comparing the coefficient according to the power of x. So we first expand the bracket. We have ax squared plus a plus bx squared plus 2bx plus cx plus 2c. Then rearrange the expression according to the power of x. So for x squared, we have a plus b. For x power 1, we have 2b plus c. And for x power 0 or constant, we have a plus 2c. Compare with the left-hand side. So for x squared, x power 2, on the left-hand side, we have 0. And for the right-hand side, we have a plus b. By comparing coefficient of x power 1, in the left-hand side, we have 0. And for the right-hand side, we have 2b plus c. And when we compare the constant in both sides, we have 3 equals to a plus 2c. Let a as subject, we have negative b. Let c as subject, we have negative 2b. So this will be our first equation. Second equation, and substitute equation 1 and 2 into 3. So 3 equals to negative b plus 2 times negative b. So we get negative 5b, hence b equals to negative 3 over 5. Substitute back b equals to negative 3 over 5 into equation 1 and equation 2. So substitute b equals to negative 3 over 5. So a equals to negative times negative 3 over 5. We have 3 over 5. When we substitute b equals to negative 3 over 5 into 2, we get c equals to negative 2 times negative 3 over 5. So c equals to 6 over 5. We already found values of a, b, and c. Then substitute the values into the general partial fraction. So 3 over x plus 2 times x squared plus 1 equal to, so for a, we have 3 over 5 x plus 2 plus bx, negative 3 over 5x plus c, 6 over 5 over the factor that cannot be factorized, which is x squared plus 1. So our final answer is 3 over 5x plus 2 plus with negative 3x plus 6 over 5 times x squared plus 1. So this is our answer. Example 16 on page 18. Express 2x cubed minus 7x squared plus 17x minus 19 over 2x squared minus 7x plus 6 in partial fractions. The polynomial in the numerator is of degree 3 and the polynomial in the denominator is of degree 2. The degree in the numerator is greater than the degree in the denominator. So this is an improper fraction. So for improper fraction, the first step that we need to do is to do long division. So the polynomial in the numerator will be px. The polynomial in denominator will be dx, the divisor. So 2x cubed minus 7x squared plus 17x minus 19 will be divided by 2x squared minus 7x plus 6. So to get 2x cubed divided by 2x squared, so we get x. So put x on top of the long division. X times 2x squared, we're going to get 2x cubed. So x times 2x squared, we get 2x cubed. X times negative 7x, we get negative 7x squared. X times 6, we get plus 6x. After multiply, we subtract. So 2x cubed minus 2x cubed, 0. Negative 7x squared minus negative 7x squared, 0. 17x minus 6x, we get 11x. Now bring down negative 19. So the remainder that we have is 11x minus 19, which is a degree less than the divisor. So we're going to start our long division here. Rewrite the fraction 2x cubed minus 7x squared plus 17x minus 19 over 2x squared minus 7x plus 6 equal to the quotient x plus 11x minus 19 over 2x squared minus 7x plus 6. So for the second term, we now have a fraction which is a proper fraction. So we're going to express the fraction as partial fraction. So 11x minus 19 over 2x squared minus 7x plus 6 is a quadratic that can be factorized as 2x minus 3 times x minus 2. So express this fraction in general partial fractions. We're going to have a over 2x minus 3 and b over x minus 2. Equalize the denominator. We're going to have a times x minus 2 plus b times 2x minus 3 over 2x minus 3 and x minus 2. By just considering the numerator, we have 11x minus 19 equals to a times x minus 2 plus b times 2x minus 3. Next, we have to find the values of a and b. By substituting two values of x, we're going to find a and b. So we can let x as 2 and x equals to 3 over 2. When x equal to 2, 11 times 2 minus 19 equal to a times 0, because 2 minus 2 is 0, plus b times with 2 times 2 minus 3. So 3 equal to b. Next, substitute x equal to 3 over 2 into the equation. So 11 times 3 over 2 minus 19 equal to a times with 3 over 2 minus 2 plus b. When we substitute 3 over 2 into x, we're going to get 0. So simplify, and we're going to get a equals to 5. So substitute a equals to 5 and b equals to 3 into the general partial fractions. So we can rewrite our original fraction, which is 2x cubed minus 7x squared plus 17x minus 19 over 2x squared minus 7x plus 6 as, don't forget your x plus 5 over 2x minus 3 plus 3 over x minus 2. So that is our final answer.